Welcome. Dear students, today we are going to discuss about diazotization reaction. In this part of the video, we will see which organic compounds show diazotization reaction, what is the end product of diazotization reaction, what is a reaction itself, the mechanism of the reaction. In the second part of the video, we will discuss about the applications of diazotization reaction. So let us start. Diazotization reaction. Diazotization reaction. Question number 1. Which organic compound shows diazotization reaction? Let me say to you that only primary aromatic amines shows diazotization reaction. Only primary aromatic amine show diazotization reaction. That means secondary aromatic amines do not show the reaction. Tertiary aromatic amine also do not show the reaction. Aliphatic amines also do not show reaction. Only and only primary aromatic amines shows diazotization reaction. The second question is, what is the end product? The end product of diazotization reaction is benzene diazonium chloride. Benzene diazonium chloride. Question number 3 is, what is the issue? What is this benefit if we are making benzene diazonium chloride? The benefit is that benzene diazonium chloride acts as starting raw material for a number of organic compounds. Let me say with the examples, chlorobenzene, it can be made from this, bromobenzene, benzonitrile, iodobenzene, nitrobenzene, lot of organic compounds, even benzene and phenol can be made from benzene diazonium chloride. So that much important is benzene diazonium chloride as a starting raw material. The next question is, how do we make it? How do we make benzene diazonium chloride? The answer to this is diazotization reaction. Let us understand the reaction, let us draw the reaction, and we will get an idea of what is diazotization reaction. Let us go to reaction. Reaction. What would you take as the substrate? What do you need? Yes, primary aromatic amine. I am taking that. Treat it with nitrous acid. HONO is nitrous acid. Diazotization reaction takes place at cold conditions in the presence of dilute HCl. Okay, this is the reactant and these are the conditions. Let us now write the product. We already know the product. It's a benzene diazonium chloride. Write this benzene structure. Write nitrogen. Remove these two hydrogens from here. In that place you take a nitrogen and write it here. Okay, how many hydrogens have you removed? 2. Write 2 bonds here. Fine. There is lone pair here. Correct? There is lone pair here too. Okay. Take this lone pair and put it here. Okay. So now how many? 3 bonds. Correct? So when you put it here, this nitrogen loses its lone pair of electron. So this nitrogen, write a positive sign over it. Correct? Now just write Cl minus here. Okay. There is no bond between this nitrogen and this Cl. Okay. This Cl minus is closely associated with the positive sign here. Okay. So that is benzene diazonium chloride. Okay. I hope you understood how this nitrogen got the positive sign. It lost its lone pair to this nitrogen and that's how this positive sign came here. And Cl minus is just in close association with this diazo salt. Nothing else. There is no bonding between these two. Okay. So now you have written it. How many hydrogen was lost from here? 2. Correct? This is the third hydrogen and the fourth hydrogen is here. So total there are 4 hydrogens that are there. How many oxygens are there? 2 oxygens. So what to do? Write 2H2O. So that is the reaction. Let us now look into the mechanism of diazotization reaction. Let me rub this. mechanism. Dear students, there are 4 steps in mechanism. 4 steps. Step number 1 is formation of nitrosonium ion. Formation of nitrosonium ion. For this, we will take nitrous acid. This is nitrous acid. Fine. This oxygen actually has 2 lone pair of electron. I am writing the 2 lone pair of electron here. The conditions are acidic. Dilute HCl is there. It releases H plus. Let this H plus go and attack the lone pair of electron here. Let this attack the lone pair of electron here. So what would result? 1 H will come here, right? And because one of the lone pair has been taken by this H, a positive sign comes here on the oxygen, right? Now to remove the positive sign, this electron pair shifts here. And what do we get? Right, H2O, lone pair is restored now, and nitrosonium ion. Note that in nitrosonium ion, nitrogen has the lone pair of electron. What it has lost is bond pair of electron, right? This pair of electron is lost, not the lone pair. Lone pair is still there. So nitrogen has lost the bond pair of electron to oxygen. So we get nitrosonium ion. This is the nitrosonium ion. So this is the first step. Let us now see the second step. Step number 2. Step 2, attack of nitrosonium ion. Attack of nitrosonium ion. Where it would attack? Now nitrosonium ion has been formed. Do you think that it will sit idle? No. What it will attack? Which compound shows the reaction? Yes, primary aromatic amine. I am going to write primary aromatic amine like this. Is there a problem? No. Right? This is the phenyl group. Okay. Let me take the nitrosonium ion. Yes. Fine. Okay. Let me react it. What would happen? C6H5 N. Let me put H like this. This nitrosonium ion, it would take the lone pair of electron from this nitrogen. Okay. So lone pair has been taken and nitrosonium ion gets fixed here. Because this nitrogen lost its lone pair of electron to this nitrogen actually becomes positive now. Now what we have got is nitrosoaniline. What? Nitrosoaniline. Let me write it. Nitrosoaniline. Right? So that is what we have got. This is step number 2. Step number 3. Step 3. Rearrangement of nitrosoaniline. Rearrangement of nitrosoaniline. Let me see. Let's rub this one and let's write this here. C6H5 N okay, and the positive sign is here. Let me rub this one now. Now there is positive sign here. To remove this positive sign, this pair of electron, it comes here. But when this pair of electron comes here, positive sign comes on oxygen. Correct? To remove this positive sign, this hydride, it goes here. So this positive sign gets removed. But this nitrogen, it doesn't have any effect because the gain of electron, why it gained an electron? To remove a positive sign. The gain of electron pair is cancelled by the loss of electron pair here. The gain of electron pair here is cancelled by the loss of electron pair here. So overall this nitrogen doesn't have any effect. It is still positive. So what we get is C6H5N and double bond here. The H is still here and double bond here NOH. This nitrogen is still positive. Step number 4, I'll rub it. Step number 4, step 4, dehydration to diazonium salt. Dehydration to diazonium salt. Let us see this is the structure C6H5NH NOH. Positive sign was here. Now what would happen? This H and this OH goes from here. This H and this OH goes from here. And what is the result? Let us see. C6H5N right? When this H goes with OH, this pair of electron is left here. When this OH goes, it takes the pair of electron with it. So this nitrogen becomes positive. Am I right? When this H goes with this OH, okay, and becomes H2O, this pair of electron comes here, this positive sign goes. So this nitrogen now has got the lone pair of electron back, and when this OH minus goes, this nitrogen becomes positive because it's lost its bond pair of electron. Now to compensate the loss, this lone pair comes here. So now we get C6H5N triple bond N. So this positive sign now goes and the positive sign now comes in this nitrogen. Now it associates closely with chlorine. This chlorine comes from dilute HCl, correct? So it associates closely with chlorine and form benzene diazonium chloride. Benzene diazonium chloride. So that is how benzene diazonium chloride is formed. Dear students, in this part of the video we have discussed reaction and mechanism of diazotization reaction. In the next part we will discuss about applications of benzene diazonium chloride. If you have liked and you have understood the class, please do not forget to subscribe the channel. Thank you very much.